Okay, welcome to the Security Plus Nugget on wireless security. And you know what? You're really in my wheelhouse now. I love wireless, and I love wireless security. I've done several of the CBT nuggets for the CWNA track, the Certified Wireless Network Administrator, CWNE, the Engineer, the Security Wireless. So this is an area that I have a lot of interest in. Here's the challenge, though. I don't really have time in the Security Plus Nugget to go into how wireless works. This is really beyond the scope of this exam and beyond the scope of this nugget. The challenge is it's a whole different ball game. We're talking about a different set of physics even. And for a lot of people, it's a quantum leap looking at how wireless actually works. And to be honest with you, we're not even really sure as human beings exactly how the radio frequency spectrum operates completely. There's still some mystery around it. However, we know it works. It's like, we can't see the wind, but we know it's there kind of thing. What we're going to do is we're going to approach the areas that CompTIA wants you to know about as far as wireless security goes. And so what I want to do is this. I'm going to take you right into the setup configuration on my wireless access point. And we'll hit some of these topics like WEP, weak encryption, SSID broadcast, MAC filtering, which can be configured in that particular interface. And we'll talk about the weakness of those things. Then I'll go into a discussion of rogue access points and their danger to your organization. And then finally, we're going to end up looking at war driving, bluejacking, and blue snorting. Is there more to wireless security? Absolutely. I did a whole nugget on wireless security, so 20 movies plus. But as far as the Security Plus exam is concerned, I'll have you ready to go. So let's go ahead and get started looking at WEP, Wired Equivalent Privacy. Okay, I'm in the wireless setup area of my DSL wireless access point / switch / router. And I want to address some of the things that we're going to talk about in Security Plus. But first off, let me just tell you that wireless was designed to be very promiscuous. The early standard of authentication, I'm talking about authentication of the devices, okay? The access point, which is like a wireless hub, and the devices like laptops, mobile devices, and workstations with wireless cards in them. There was basically two forms of authenticating devices. There was open system, which is the default, which basically says if you come in range and we can get on the same wavelength, I'm going to go ahead and let you communicate through my access point. Now, why was it done in such a haphazard way? Well, the whole thing about wireless was to extend to the masses connectivity. Okay, so it was designed that way to be an open kind of everybody comes in and communicate type of activity. The problem is we started bringing wireless into the corporate network, and we started having teleworkers using wireless out in public places like coffee houses and coffee shops and Starbucks and airports and hotels. Now, the other kind of authentication is shared key. And shared key is just simply where I put in a password on my configuration on my laptop, and then the administrator on the access point puts in a password. Now, these passwords or keys are called static WEP keys. And as I mentioned, WEP stands for Wired Equivalent Privacy. And you can tell by the name of this what they were trying to do. They were trying to get the same kind of equivalent privacy that you get in a wired network or a wired Ethernet. And just the name itself was a mistake, because it gave people the impression that if I'm using wired equivalent privacy, that I've got equivalent privacy that I have on a local area network using Ethernet or fast Ethernet, and nothing could be more farther from the truth. That was the goal, but the problem is there's some inherent major weaknesses with WEP. Not with the protocol that it uses, okay? The encryption protocol it uses is RC4, which is really a very strong standard. It's the way that WEP is implemented. And if we go to this wireless setup here, we can see that I can choose encryption. Now if I choose none, and this is by default what devices want to do, this is null authentication, which simply means if I can connect to you using the physics of RF, I'm going to be part of your area, part of your service set, and away we go. Okay, if I have a neighbor that has this set to none, I can just go and piggyback off of their bandwidth and get on the internet and surf the web, and it's done all the time. As a matter of fact, people who do what's called war driving or war walking, and we'll look at this at the end of the nugget, do this same thing. They look for open authentication systems, and a lot of times they'll get up on the internet and they'll make like a database of these places and they'll advertise them on web pages. So I come into town, I can go find a list of open authentication access points where I can just go piggyback bandwidth and get on the network. The problem is, if it's an area that deals with secure traffic, they're sending sensitive data communications over that wireless network. I can actually use an arrow peak packet sniffer and pull that information out of the air. It's bad. So WEP 64-bit is one of our options. The problem is 64-bit is a little bit better than the original 40-bit WEP, but it still shouldn't be used in a corporate environment. And there's several reasons. Number one, because static keys are being used most often, that means that these keys or these passwords get stale. Number one, they're not probably strong. They're probably using the name of the access point or the company or something like that, and they're static. So the more traffic that goes from this access point to the devices, eventually I can crack it, because WEP uses what's called an initialization vector, IV, and that information, the IV, is actually stored in clear text. So clever hackers have already broken WEP. So you don't want to use 64-bit. At your home, using WEP 128 is okay, because it would take so much traffic generated from your home for someone to eventually do a crack against this. It's probably not going to happen. Now what the industry did in the Wi-Fi consortium, they had kind of a stopgap measure between WEP and the standard that we're at now. That was called WPA. At least try to use WPA in your environment. That adds a lot of extra security mechanisms in there. Extra security controls like per user, per frame keying. Okay, so you've got a generated password for every user and every frame of that user. You've got sequence counters. You've got larger initialization vectors than WEP. WPA uses a 48-bit IV. It's also got what's called TKIP, Message Integrity Code, or MIC, Michael, which is used to check the integrity of the frames to detect unauthorized changes. Okay, so they put a lot of new features in. Where we're at now is WPA2. WPA2 is the Wi-Fi standard. That's the name for the new industry security standard, 802.11i. Write that down, 802.11i, or RSNA, Robust Security Network Associations. Okay, let's go back to the wireless setup. First of all, SSID. This is the default, and this is really kind of like a work group name, okay? So the work group of devices that are going to communicate with this access point, okay, this hub, are going to all have the same SSID configured. The problems here, and I did this on purpose, is I kept the default SSID, which is called Zoom. You don't want to do that. You want to change that to something that's not the vendor supplied SSID, okay? Number one. Now what they'll also tell you is one of the security mechanisms that's used on access points, especially in small office, home offices, is they say, you know what, we're going to hide the SSID. So as this access point is kind of advertising itself within its area that it can communicate with, it's going to hide this name Zoom from those frames, so that unless a client is specifically configured to communicate with Zoom, it's not going to see initially those frames out there in the RF. So putting this on true gives me a false sense of security, because here's the problem. This SSID will still be communicated in other transmissions, okay, to other devices, and they can still be pulled out of the air with arrow peak. So this is not a secure measure either. People will do this and go, you know what, I'm hiding my SSID, so as their laptop, somebody drives by the front of my house and their laptop is scanning, they're not going to initially see me. And that's true, okay, but if I'm clever enough with arrow peak, I can find out what your SSID is, okay, or I can just guess. I can just go through a laundry list of all of the vendor defaults and configure my device to say Zoom or Linksys or Netgear or whatever. And if I can configure that and you're using open authentication, okay, no passwords, no keys, I'll be able to piggyback your network connection. So that's one option that they want you to know about. Under profile here, it's just basically saying what type of .11 am I using, okay? The one that's used most often now is .11g because this is backwards compatible and it gives you up to 52 megabit per second of theoretical bandwidth. Now we're not even getting half of that because we're dealing in a contention-based environment with a hub. So I have to contend for that bandwidth with everybody else in my area, and also it's using carrier sense multiple access with collision avoidance. And you can see I can say I want 11G only, 11B only, so this has got some flexibility. As I said, with encryption, you want to use at least WPA, WPA2 even better. Now the problem is, whatever client I'm using, whatever laptop, for example, has to support this same type of encryption. Most of them, if they're relatively new, last couple of years, they're going to support WPA and WPA2. As a last resort, if I have to in my home office, I'll use WEP 128-bit. Chances are no one's going to crack that. Now, my passphrase, I cleared this out because I didn't want you to see my password as if it really matters. But this should be a strong password. In other words, it should be 8 to 10 characters with at least 4 character types, okay? Uppercase letters, lowercase letters, numbers, and symbols, okay? Capital D, little y, number 7, asterisk, %, little k. It reminds me of that movie. I don't know if you've seen the movie Nacho Libre, but he sends a letter to this girl, and it's like, it's XX, little x, little x, little x, big O, and he's like, big keys, little keys, big keys, little keys, little keys. It's cute. Anyway, so make sure it has 4 character types. Check this out down here, 802.1x authentication. Wow, that's a cool feature. So I'm going to put my passphrase back in here, and I'll meet you on that next screen. Now the cool thing about 802.1x authentication is that it works over a wired environment and a wireless environment. So in the OSI model, it kind of sits on top of Ethernet and .11 wireless. Why is that good? Well, for your company, you can put in place an 802.1x implementation, and it can work for your wired and your wireless environment. And what it does here, you can see it says authentication server. It adds kind of these 3 parties to this process where I've got my client laptop, for example, which is called a supplicant, okay? It is begging to be on the network, okay? It's a supplicant. That's what it does. It's asking, okay? Then there's a intermediary device, and that would be my wireless access point, which is this one we're configuring right now. Then you add a third player to the device, the authenticator, and that device is going to be a radius server. Now, it's no big deal. I mean, you can make your Microsoft Windows Server a radius server. You can go up on the internet and get freeware radius servers. There's a bunch of them that run on Linux. You can do this in your small office, home office. It's not that big of a deal. Just have a radius server sitting there. And I can just put in the IP address of the radius server and a shared secret password that's configured on the radius server and on this particular access point as well. Make sure it's a strong password. And we're not going to configure this, but this gives me now .1x authentication. So what happens is this laptop wants to authenticate with the access point. The access point takes the credentials from the laptop, and it goes to the Radius server, and it authenticates with this third party. So you can add this into your environment or your small to medium-sized business environment. It's a great solution. As I mentioned, it runs on top of Ethernet and on top of wireless. I'm going to go to the advanced setup area here. First let me go say local again and go to advanced setup. And you can see on most access points I've also got firewalls that are integrated into those access points. So I can go to the firewall here, I can enable the firewall and choose a security policy configuration. And notice I can add rules. I can add, for example, external rules for my access to the internet. Click on policy and go in here and add policy rules. And you can see that I can filter based on source addresses, destination addresses, protocols that equal TCP or UDP, so I'm permitting or denying, okay, source ports, choose the ports I want, inbound traffic, outbound traffic. So I can block or only allow certain IP addresses, certain protocols, certain ports. This is a firewall. Now, check this out. Let's say that this is at your small to medium-sized business or at your home, and you want to actually have a server in your home that people access, a bulletin board server, a gaming server, whatever you want. You can create your own DMZ, like I told you about, your own DMZ, which is actually just connected to a switch port on this access point, because my access point accepts wired and wireless. So I could have a server on this access point, people could access it over the internet, and I can create a DMZ firewall just for that access point. And I could protect that from the rest of my network. So you've also got firewall configuration as well. Now, the other thing that the Security Plus exam wants you to know about is this concept called MAC filtering, which is often used as a security measure, but it ain't. I'm going to go ahead and click on this MAC filtering button, and all of your access points are going to have some type of mechanism. It may be on the main wireless setup screen, or it may be its own area. And I'm going to come in here, and by the way, mine is disabled. And here's the thinking, and this goes along with what a lot of switches will do for what we call port security. They will say we only want to allow certain MAC addresses to connect to this port. The same thing here. We want to go through our home or our small business. We want to say, what are the MAC addresses of the systems that are going to access this access point? And I'm going to go ahead and name them, give them some type of label, and then actually manually configure these MAC addresses of all the systems. And then only those MAC addresses will be able to authenticate to the switch port. Now you can also do this in a larger organization with that 802.1x authentication that I talked about earlier. We can also leverage that to have a list of MAC addresses, and only those can connect to switch ports, or in this case, the access point. And of course I can keep adding these in there and just have a MAC filters list. Now, this is used as a common way to get security, but let me just tell you something, it's not secure, because there are programs out there that are easily downloaded that can spoof MAC addresses and that can change MAC addresses. So in your home, this is probably a pretty cool little feature to use. In a large organization, you cannot depend upon this MAC filtering capability. Even though CompTIA wants you to know about it, it's not a bad feature for the small office, home office, but it's not your full featured security for a large organization. Now, something else about your access point. I'll go back over here and under administration, there's an area for admin password. Let me just tell you, when you get your device, regardless of who the vendor is, there's going to be a default IP address that you connect to this device and to get this web-based interface. As you can see here, I went to my browser and I typed in 10.0.0.2 to get to this particular graphical user interface to configure this. However, there's an admin password that typically is in like the instruction booklet or the documentation that comes with the access point. So you want to change that. It usually defaults to the username being admin or administrator, and then they'll give you some type of password which may just simply be like the name of the product. And here's the deal. Hackers and nefarious users know this, okay? And they can get physical access, or they can get to my device through this IP address, they'll try to use default passwords and credentials like admin and Zoom, for example. So you want to come into your device and you want to change the defaults to your own username and then a strong password, 8 to 10 characters, uppercase, lowercase, numbers, and symbols. Now, CompTIA wisely wants you to know about rogue access points as a vulnerability and threat to your wireless networking environment. But I want to go beyond that. You want to be aware of any kind of rogue device at all. I mean any unauthorized device on your network. Now, a rogue access point, as you can see here, here's a picture of a D-Link DWL G730 access point. It's really small. Now, it's not this small, but you can look at the power supply next to it and you can get an idea of how small this thing is. And this is literally an access point. It's under $60. And you can bring it into the organization. It is a wireless hub access point. And with a little bit of information, I can do all kinds of bad things. For example, I can have it connected to my laptop and run AeroPeek and do wireless sniffing and scanning in a corporate environment. And it's so small, I can literally put it in my pocket or in my jacket pocket. Now, a rogue device is anything that's unauthorized. A rogue access point, a rogue bridge. It could be a laptop that is simply a wireless device that's unauthorized in my organization. It's got a wireless radio built into it. Let's say a new Toshiba. The antenna is behind your screen there, and it's a rogue device. It can create what's called an ad hoc network with other wireless laptops, kind of in the same way we used to create infrared networks between two ports on two laptops. So we can create what are called ad hoc networks, where we're not even using an access point. And if the firewalls aren't configured properly, I may be able to hop from the wireless network into the wired network where I can do all kinds of things. So a rogue access point, and let me tell you this, I could install a powerful PCMCIA card into my laptop. I could hack the driver and I could use what's called a soft AP. This isn't a soft AP. But a soft AP, a soft access point, is designed to work with my network interface card, and it's just simply software installed on my laptop, and there's even little external antennas I can use, and I basically have an access point. Now, where can these access points be? Well, they could literally be outside your building. Okay? If somebody can drive up next to my building and the range of my internal access points go beyond the perimeter of my building, I could just basically sit out there. I've done this before, sitting outside of a university, for example. But they can be placed in your organization under desks. They can be placed up in the ceiling panels up there, in closets, behind a planter with a fake plant in it, behind books on a bookshelf, behind a bookshelf. I mean, you name it. They can be slipped in there anywhere. And if you aren't using strong security mechanisms, your organization is very vulnerable. The other thing about a rogue access point is it can serve as a rogue DHCP server. Okay, so my access point comes in there and it starts to intercept with the man-in-the-middle attack other wireless clients that are out there, and it will attempt to dole out DHCP information to those wireless clients that are roaming around the organization. Suddenly, they're on my network, and I can do all kinds of things. If I can get privilege escalation on their laptops or their mobile devices, I can get all kinds of information. I can hack, I can attack, I can do all kinds of things. And again, so a combination of a rogue access point and something like AeroPeek, a packet sniffer for wireless, makes this a very dangerous situation. And so beyond rogue access points, basically any device that's unauthorized shouldn't be in the organization. And that's why using 802.1x authentication can be so powerful, because it can overlay your network infrastructure, both wired and wireless. Okay, next we're going to talk about war driving, which is a really fascinating subject, but I want to turn you on to something. I'm up at CBT Nugget's website, and since you're watching this particular Security Plus Nugget movie, you're already registered at CBT Nuggets. So if you're registered there, you can log in, and you can go over here to where it says free videos. Let me turn you on to something. If you go to free videos and you scroll down here, or come down to the bottom where it says wireless videos, check this out. There are 3 free wireless videos, and I want you to view all of them. But look at this one. This is one I did for the CWNA Nugget, and it's called Let's Go War Driving Wireless Land Discovery. I really want you to go up to CBT Nuggets and watch that movie. It's free, and it's a great supplement to this particular nugget in Security Plus, because I actually go out in my car with my soft AP and my AeroPeak scanner, and I'm driving around my hometown to universities, by the Air Force Base, by businesses. I literally walk through the process of going through and war driving these different neighborhoods, these different areas, and showing you the results in my wireless scanner. It's a very, very fun nugget. You should go check it out. Now, once you view that, don't hesitate to go and watch Common Wireless LAN Applications and Intro to Wireless LAN Analysis. And it'll just give you a more strong support and underlying foundation for wireless technology. So I kind of wanted to turn you on to that. Let's go ahead now and go kind of back to the drawing board, so to speak, and we're going to talk about war driving. Now, war driving is a term that's been around. I don't know if you remember that movie from the 80s, and maybe in the early 80s, War Games with Matthew Broderick and Leah Thompson, and he had the dial-up modem. He had all the cool equipment. He was the geeky kid, and he had the dial-up modem, and he was dialing in and playing this war game with some military site, and he ended up actually getting involved in a real nuclear incident. Well, war driving really came from the whole telephone concept of kind of war dialing, all right? But war driving is what we do in a wireless environment, and you'll see in the video, you basically drive around with an antenna on your wireless radio and some software, and you're looking for a lot of things. Number one, you're looking for people who are using null authentication. In other words, they've got no authentication whatsoever, just the default setting where it's promiscuous and anybody within range can connect to their radios or their access points. You're looking for that. Then you're looking for people who are using WEP and are possibly using default SSIDs, again, like Netgear or Linksys, and maybe they're using weak WEP keys, things like the name of the access point, their company name, stuff like that that's guessable. Even if they're using WEP and they're using the 40-bit version to 64-bit version with the right software, you can crack this. Now, what war drivers do is they go one step further and they do what's called war chalking, where they'll go to the building and they'll use a special type of tagging, with either chalk or paint, and they'll literally on the outside of the building or on the sidewalk, they'll actually put down symbols, and I'm not going to go as far as laying all that out for you. You don't need to know this for the Security Plus exam, the symbology, but they put symbols down that basically tell people that it's a null SSID or what the SSID is and whether they're using WEP and things like that. So they have a whole vernacular so that they can drive around. This is really hot in Europe, where they can just basically drive around and get free internet access. That's the main goal of war driving, is to get free internet access. But it can also lead to huge vulnerabilities for companies as people war drive around and around. And it's very common to war drive like universities and neighborhoods, drive near buildings that maybe have some wireless hotspots that are misconfigured, those types of things. So war driving is a phenomenon. It's not necessarily illegal, but it may be unethical, okay, to use your neighbor's internet access. But you know what? It happens all the time. But for a small business who's using null authentication or static WEP keys, it's a huge vulnerability. So we want to be using WPA2 or 802.1x with a radius server in the enterprise organization to protect ourselves from rogue access points, rogue devices, and war drivers or war driving. Again, check out that video. I know you're going to like it. Our last couple of wireless terms are bluejacking and blue snorting. There's also related blue snarfing to that as well. Obviously, the common denominator here is blue. When we talk about blue, we're talking about Bluetooth. Now, Bluetooth is also a wireless technology, but it's not compatible with the 802.11 A, B, and G. And it's really meant for short-range communications from fixed or mobile devices in what we call PANs, or personal area networks. We've got all type of Bluetooth devices out there. We've got Bluetooth gaming controllers, mobile phones, Bluetooth telephones, laptops, PCs, printers, Bluetooth GPS receivers, Bluetooth digital cameras. All these things, they operate over the 2.4 gigahertz short-range radio frequency band. Now, bluejacking is basically the process of just sending unwanted spam messages over Bluetooth to devices like mobile phones and PDAs and laptop computers. You'll also see them sending what are called V cards that have messages in there, unwanted, unsolicited messages in there. It's typically a harmless activity. However, as we're starting to see this influx of guerrilla marketing through this bluejacking process, we're also seeing vulnerabilities as Trojan horse programs are now being sent to Bluetooth devices. And that's what CompTIA wants you to understand here. Blue snarfing is basically illegal hacking of mobile phones using Bluetooth. So I'm going to put blue snarfing, which you might want to know about, illegal hacking, okay, of your Bluetooth mobile phone. Blue snorting is interesting. Snort is actually a free open source network intrusion detection, which we've talked about, network intrusion prevention software that's used on wired networks, okay, packet logging, real-time traffic analysis on your IP networks, but there's also wireless versions of Snort. So if we've got Snort protocol analysis software that's used on a wired network for intrusion detection, intrusion prevention, and then we've got wireless Snort, then also we might want to consider the fact there's probably Bluetooth snorting going on. So blue snorting is basically the same type of thing. It's introducing IDS and IPS protocol analysis and searching and matching of packets in a Bluetooth environment. So that's what blue snorting is. So don't forget, .11 isn't the only game in town out there. .11a, 11b, 11g. You've also got infrared that works in a slightly different spectrum, and of course Bluetooth as well. So keep that in mind, and that's it for wireless security. Well, gosh, I wish I could spend all day talking about wireless security. It's one of my favorite areas of interest, but I can't. So let's kind of take a look at what we covered here in this nugget. These are the requirements that Security Plus from CompTIA wants you to know about wireless security. Again, there's entire books written about this, but check out those free videos from CBT Nuggets as well. And also, let me just mention that there are entire wireless series that CBT Nuggets offers as well, if this is something that you are interested in, because it is pretty fascinating. In this nugget, we looked at weak encryption, specifically WEP, talked about that SSID broadcast feature, which is not security by turning that off. MAC filtering, which can provide some security for the small office, home office, but is not an enterprise solution, whereas 802.1x with a Radius server is a solution, as we talked about. Radius, that should be an I-U-S. Rogue access points, really any rogue device we looked at being a threat or vulnerability. And then finally we ended up talking about war driving, bluejacking, and blue snorting. And while I mentioned war driving, there's also, you don't have to do this in a car. You could walk around with the device, or you could get on your bike and do it. So there's war biking, there's war walking, any type of transportation. It's doing scanning and protocol analysis of wireless networks. Well, I hope this CBT Nugget was informative for you. I want to thank you for viewing. We'll see you in the next nugget.